Okay, so let's switch to the work package 2 on programming models. So first of all, we have to mention that the first deliverable has been delivered. So it was at month 6, and it was mainly an improvement of the work plan for each code according to the preliminary results every teams get at the beginning of a project. So before speaking about the codes, I would like to mention that we are currently organizing a workshop on performance evaluation. Normally all of you have been notified by email. It will be in Erlangen from the 7th to the 10th of November, focusing on node level performance and how to detect bottlenecks and how to understand them, and you will also have first optimization guidelines. This workshop is organized with FO, but also with POP, another COE, as EoCoE. And for the moment, we have 8 attendees, and so we have still 6 available possibilities if you want to register. And here you have the links. Concerning the workshops, so the first workshop will be more theoretical. It will be more like courses with some hands-ons. But the next ones will be different. Then we'll switch to another format. We'll do hackathons, where every teams will be able to bring their own code, and where we will deeply work on the code to optimize them. So we plan to organize a workshop like this 6 months after the next workshop, the performance evaluation workshop, so in spring 2020. And we'll probably organize at least 2 hackathons, but this is still under discussion. So let's now switch to the different codes. First of all, the Wind Scientific Challenge. So the first code is Alya. So concerning the WP2, Alya's team has been working quite well, actually. They have already good results on the GPU extension of the code, with an OpenACC implementation for the general aspects, and for the solvers a CUDA 1. They have been working on the CPU-GPU co-execution, which is a nice feature for the next generation of supercomputers that will mix different kind of architectures. So they use space filling curve and load balancing system to find the optimal load balance between the devices, so the GPU and the CPU. And the first test have shown a gain of 20% on the IBM machine they have at BSC. So just a simulation to show you. And yes, there are preliminary development of the dynamic coupling between fixed and rotating mesh, as it was also presented in the WP1 presentation. So for each code, I've done, I would say, a graphic like this of the work plan. So for each code, the purple color will be what has been updated, has been put in the previous deliverable. So for the deliverable at month 6, we have redefined all the work plan, and the work plan, the defined work plan are supposed to be the purple color. Here you have the month. Here you have the task or the subtask, depend on the codes. In green, you have what have been done so far, and in orange, what is currently in late or lagging behind, I would say. So for Alya, everything is going quite well. They have been focusing mainly on the 3 aspects: so co-execution, mesh partitioning, and dynamic coupling. MPI overlapping is not yet addressed, if I understood well, but it's not a big deal since there is a lot of things to do here, and having all these tasks already underway is already a very good thing. So for the wind scientific challenge concerning WalBerla, it's also going on quite well. So they have preliminary tests demonstrate the potential of the LBM method. So they have done a performance test to determine if it could be a good competitor, a good comparison for Alya, and they are now recruiting a postdoc that will be operational before the end of the year between FO and EFPEN. So nothing specific to mention here. So they have a lot of tasks, but since the postdoc will arrive very soon, it's just a question of months. It will start at the end of the year. Concerning now the Meteo Scientific Challenge, so for EURAD-IM, which is the only code in the work package 2, so thanks to the experts of Elagon, some bottlenecks have been identified, as well as vectorization issues. So now they are continuing this preliminary work to find solutions. Additional investigation is supposed to be done during the workshop. And currently they have code issues when running on a very large number of codes that is creating some delay in the first 2 tasks of the project, but this is something that will be solved hopefully. They have the first implementation underway, and a recruitment for the WP2 and the WP4. So here we are in terms of work plan. So for PDI, for the moment, nothing done, if I understood well. However, all these tasks have been started. So code refactoring and GPU adaptation, although it was supposed to start later. So here the blue color means that the tasks have been already started before the due date, I would say. Concerning the material scientific challenge, so we only have PVnegf and its successor in our work package. So we have redefined completely the work plan, and now we have a very detailed strategy to optimize the code that is summarized here in this in a graphical way. So the idea is to optimize PVnegf and to generate to create a new code, a successor. So here first to rewrite the code in a simple way, like a mini app, with only the node level optimization, the node level parallelization. Then to add progressively functionality from PVnegf, except the multi-band aspects. Then to have the full parallelization with MPI and OpenMP. And Myson 4 is, I would say, the complete optimization with advanced features for exascale and extensive computing. And Myson 5 is supposed to be the addition of the multi-band aspects. So as Eduardo mentioned, now they are currently thinking I would say changing PVnegf, so it's still under discussion, but this is what we have now from the last deliverable. And so in terms of agenda, so the rewriting of the code has been started, but for the moment it's I would say it's stopped until further discussions. Concerning hydrology, first I will speak about ParFlow. So there are actually 2 branches working separately in ParFlow. I would say the refactoring of the solvers with improvement of the solvers and also GPU implementation. And at at the same time the AMR implementation, so adaptive mesh refinement. So this aspect is covered at CA. We already have the postdoc working on it, Jose Fonseca. He has already started to adapt the communication between the children and the parents of AMR. And he has already started to work on the numerical schemes that need to be modified for the AMR aspects. And concerning the GPU implementation, so ParFlow have been people from ParFlow have been discussing with people from IPRI to find some I would say inspiration, because the two codes share same implementations. We are also, for this aspect, working with WP3, and the GPU implementation will be covered at ULISH with the recruitment of the postdoc. So it's very recent, and this will change a bit the agenda that we have updated for the deliverable. In fact, this is what was supposed to be done, and at first we were thinking to mix GPU and AMR at CA, so to have everything done by just one postdoc. But thanks to the recruitment at ULISH, we'll be able to remove the GPU aspects from the postdoc at CA, so that we will be able to work on AMR until month 26, and here we'll have much more time to focus on GPU. So concerning AMR, the things are going on pretty well, so we have already started to work on the implementation. About SHEMAT, nothing to say except that the postdoc will arrive 1st of October, so the work will start very soon. We have this task about ExaTerr. So ExaTerr is supposed to be a from-scratch platform common to SHEMAT and ParFlow. It should provide AMR function and GPU capabilities. So this was designed in the proposal. Problem is that now, looking at the resources we have in WP2 and looking at the difficulties behind these two aspects, we don't know how we'll handle this huge task. So it's still here, but we'll have at month 18 we'll have to decide what to do with it with this. According to the results from the GPU and the AMR task. About the fusion, so here the leading of Guillaume Lattu has been quite important. It has modified a lot the work plan. Nonetheless, before leaving, Guillaume has done quite a good job. So we have already performance result with a C++ prototype that was done by Guillaume Lattu, and it led to important results for GyselaX. First, the C++ will be abandoned because it shows limited advantages, limited impact, and limited interest for physicists. So here I'm just explaining what people from GyselaX have reported. The task-based approach is no longer an option as well. Although Guillaume has worked on this aspect, it's the same for Cocos. So all these new features will not be in the new GyselaX. They prefer to modernize the Fortran implementation, so that they will have a notion of modularity. PDI will probably help to achieve this goal. PDI will not be only used for the IOs, but also to improve the modularity. And they want to focus the implementation on ARM-based computers. and this may be done in collaboration with Japan, with the RICAN. About the recruitment, so there will be 3 postdocs, one on PDI aspects at CEA, another one for numerical physics, and a postdoc to work on the optimization. So since we only have 7 months here, this is the reason why we want to merge these PMs with another institution so that we can really work deeply on this aspect. There is also 2 PhD, one on computer science and half PhD that will start with an internship as well. So here is the work plan. So it will be probably completely. Here it's a lot of PMs that does not correspond to what we really have. Only the prototype of GyselaX has been started, and here only the 7 months here have been allocated to the optimization, but this will change as well if we can find if we have this collaboration with the RICAN. About the PRACE and the competing resources, so as you know, it's renewed every 6 months, and the new resources allocation will come very soon. So when I have some news, I will send you an email, and you will have to reply me with what you want in terms of supercomputers and number of hours, as we did 6 months ago. Okay, thank you.